Just decided to plug this in at the end. You can see now it self-oscillates and runs, right? But let's look how the base waveform looks like. I'm scoping across base emitter. Let's see how the waveform looks there. Because as you can see, I'm using very simple circuit there. Just the winding and resistor and a diode to protect the base from the reverse voltage. Let's see what the scope has to say. Let's kick start it. There we go. Okay, what you see there is half a volt per division and 5 microseconds for sweep. Hi guys, Mr. Johnny here. Yet another update about this switch mode power supply. You saw in the previous episode that the waveform on the basis looked pretty horrible. So I went and replicated what is used in Type AT switch mode power supplies for computers. You can see it's quite more elaborate. It uses 4 resistors, as you can see there, 1 diode and 1 electrolytic capacitor for 1 channel, obviously. You can see diode 33 ohm, 2.2 kilo ohm, sorry, 470 kilo ohm and 2.2 ohm right there, and 1 microfarad capacitor. Right now I don't have the controller connected, as you can see there, but it starts up just fine on itself, just like it should. Let me plug it in, and you see that it works. The transistors are cold, which is nice. So now I'm gonna connect it to the controller, put the scope on the base of the transistor, and we will see how different the waveform is gonna be in comparison to the other one. Okay, I'm scoping on the lower transistor just like I did before. Scope is set just like I did before, half a volt per division vertical, 5 microseconds sweep. Plug it in. A lot different waveform. Let me try to nudge it down. Focus the trace. That looks good. As you can see that the middle graticule, that one, this line is 0 volts. Which is weird. So it should be, I reckon it should be about, 1 division top there, because that's a base emitter junction drop, but oh well. It works, and you can see that negative spike. But that's normal. That negative spike is due to that capacitor discharging. Looks much better. It doesn't have ringing. This spike is actually wanted. It's to make sure that the transistor is turned off very fast. Let me check for the barely warm. Not a problem. Especially with this rubbish construction. If it's gonna be on the board, it's gonna perform so much better. I am an idiot because I had the probe set to ×10 range. Let's take a look now. That's more like it. You can see that we're about almost 2 divisions on the top. So almost what's that? We do still have that little thing there. I guess it's because of the leakage inductances on the pore, on this construction. Leakage inductance, for example, is this and this. That's an inductance which is not coupled to the secondary. Okay, now take a look at the waveform across the primary. It doesn't look all that great. Very sloppy edges for some reason. That's why the transistors are barely warm. They should be stone cold. They should not get warm at all with this kind of load. So yeah, I will have to go and do some more research. Thanks for watching. See you.